However, there are some things I can do for simple functions here. For example, if I have a linear thing inside here, I can work it out. For example, the integral of 6 cos 2x dx. I'm going to put brackets here to make sure it's clear. Well, this 6 is going to stay out the front. Cos 2x. Well, we just decided the integral of cos was sine. If I was differentiating sine 2x, the 2x wouldn't change, so that's why I know it's going to be 2x. But then I would be multiplying out the front by the 2. So when I was differentiating, the derivative of sine 2x is 2 cos 2x. So when I'm integrating, I'm going to get a half. It's a half of 1 over this number, sine 2x, plus my constant, which I can write as 3 sine 2x. Let me give you another one. Different one from what I've got written down. Let me make another one up. Minus 3 sine 4x. Okay, the minus 3 is going to stay out the front. What's the integral of sine? Well, we decided the integral of sine was negative cos. So it's negative of cos 4x. But if I was differentiating the cos 4x, I'd be multiplying by 4. So to cancel that out, to do the opposite, I've got to divide by 4 plus my constant. So I've now got, what have I got? 3 quarters cos 4x plus a constant. Another one. The integral of 3 sine x on 2. Well, 3 out the front. Integral of sine, we decided, was negative cos. Negative cos x on 2. But then I have to divide by the multiple of x, which is a half. And dividing by a half is the same as timesing by 2. Shall I write divided by a half for the moment for the first line? So I'm then going to have negative divided by half is the same as timesing by 2. 6 cos x on 2 plus a constant. Remember, always, the thing inside hasn't changed. Let's mix it up a little. The integral of negative 6 sine 2x plus 1. Okay, negative 6 times something. If you're careful, you can go, the integral of negative sine is cos. I'm not going to do that here. I'm just trying to give you some simple tutorials that you can follow. You can do that directly if you want. Just cancel out the negative in one go. Here, the integral of sine is negative cos. The thing inside has not changed, but I have to divide by this 2, and only by that 2. Why? Because if I differentiate this, the cos, I'm going to get the derivative of cos being the sine, and the derivative of the inside, which I'm multiplying by. Derivative of this is 2. So when I'm multiplying, when I'm differentiating, I'll be multiplying by 2. So when I integrate, I have to divide by the 2. Okay, negatives negate, 6 over 2, 3 cos 2x plus 1, plus my constant. I forgot at that time. Let's try another, like that one. The integral of 2 cos negative 5x plus 3. Well, leave the 2 out. Integral of cos is sine. Thing inside doesn't change, but I'm going to divide by the derivative inside, negative 5, plus a constant. Now here, I mean, you could rewrite that as negative 2/5, but it's not really any different. Now this trick only works if this is linear. If this is a more complex function, you cannot do it like this. It is not that simple. If you don't believe me, try integrating the way you think it should be, and then differentiate the thing you've just found as the integral and see if you get back to where you started.